Hello everyone, welcome to the control systems. This is part 1 of lecture 5, block diagram, and this is the outline of today's lectures. So we begin with the introduction to get you familiar with some terminology and intuitions before we proceed further. A control system may consist of a number of components, and in control engineering, to show the functions performed by each component, we commonly use a diagram called block diagram. And such diagram depict the interrelationship that exists among various components. This is the formal definition of a block diagram. So basically, a block diagram of a system is a pictorial representation of the functions performed by each component and of the flow of signals. For example, in this figure, this is a typical feedback control system, and I am not going to tell you what happened under the hood right now, but you can get some ideas by just looking at the figure from a high level perspective. For example, you can see the plan block, sensor block, actuator block, controllers block, and how the signal are connected. And because of its high level perspective, it may not offer the level of detail required for more comprehensive planning or implementation. So the block diagram will not show you every wiring, every switch in detail. However, this provides a quick and high level view of the system so that you can rapidly identify points of interest. Okay? And there are some terminology that you need to get familiar with when you work with block diagram. For example, summing point, branching, and the block itself. Okay, so it is important that the quantities being added or subtracted have the same dimensions and the same unit. Okay, uh, otherwise you will be having a hard time. For instance, if you use Simulink, then the Simulink will flag errors due to the dimension mismatch. Okay, and if you don't verify the unit, then you will be in serious trouble. The software won't tell you the problem, so it is vital to check the dimension and the unit at the very first stage. Okay, it is very simple but very important, especially when you deal with complex systems. Okay. Another one is branch point. Okay, it's a point from which the signal from a block go concurrently to other blocks or summing point. You can see right here, it is important to know that the signal come to this direction and the signal come to this direction are the same. And at the end of this class, you will be able to understand the concept of open loop and closed loop system in terms of transfer functions. You will be able to manipulate the block diagram and use it to represent the control system. You will be able to do some transformation. And last but not least, you will be able to do the block diagram reduction. For example, you have a very complicated system and they are interconnected, and you can simplify it.